If you're into manifestation, then you've probably heard that quantum physics suggests that we as observers can influence reality. But is this true? And if so, how could something seemingly non-physical like our consciousness have a tangible effect on the physical world? In this video, we're going to go deeper than ever before into the science that correlates to manifestation. Not only am I going to explain the quantum physics experiment that sparked this idea, I'm also going to explore a model that explains exactly how our consciousness could physically shape reality. My name's Georgia. I have a master's degree in consciousness, spirituality and transpersonal psychology, and in my free time I love to research manifestation and the science behind shifting our reality. Now, the law of attraction is a fascinating concept, but if you're like me, it's not enough to be told what you have to do, you also have to understand why you are doing it. So this video is for all of you who have an analytical mind and want to understand manifestation from a scientific perspective. Today I'm going to go deeper than any manifestation video ever has, and I'm going to explain a model which suggests an exact process by which our consciousness can exert a physical influence on reality at the quantum level. Now, before we explore the model, we first need to understand a crucial quantum physics experiment, the double slit experiment. Without understanding this, the model will make no sense at all. But if you are already familiar with the double slit experiment, I will leave timestamps in the description so you can skip this part if you want to. So let's look at the basic setup of the double slit experiment. Essentially, we have a wall that has two slits in, and behind that wall we have a screen. Now, we're going to be sending things through those two slits, and what we're interested in is the pattern that's going to be recorded on the back screen. Now, I want you to imagine two different scenarios. In the first scenario, we're firing particles through the two slits. You can imagine these as tiny bullets. So what we would expect to happen here is that each particle or bullet is going to land in one of two clusters on the back screen. Now, these two clusters are going to be directly opposite the two slits. Now imagine a second scenario. This time we're sending waves through the two slits, like light waves for instance. Here what happens is the wave goes through both slits at the same time and interferes with itself on the other side to create a striped pattern on the back screen. This is called an interference pattern, and it's the result of the crests and the troughs of the wave either adding together or cancelling each other out, which results in these light and dark patches. So we have two very different patterns depending on whether we send particles or waves through the two slits, and these patterns make complete sense. They're exactly what we would expect based on the behaviour of particles and waves. Now let's look at what happens when we use quantum particles in the double slit experiment. For this example, I'm going to use electrons. So what are electrons? Essentially, all of physical matter is made up of tiny little building blocks called atoms, and atoms consist of subatomic particles. So in the centre of an atom we have the nucleus, which is made up of protons and neutrons, and around the nucleus we have electrons. So electrons are a type of subatomic particle. They're an incredibly tiny particle of matter. So what happens when we use electrons in the double slit experiment? We're going to use an electron gun to fire electrons one by one through the two slits. And what we're interested in, again, is the pattern that is going to emerge on the back screen. So what we would expect to happen is for two clusters to form directly opposite the two slits, because we would expect the electrons to behave like particles, because they are particles, right? But instead we actually get an interference pattern, as if the electrons are behaving like waves. This is very strange. It's as if each electron is going through both slits at the same time, like a wave, and interfering with itself. So this suggests that the electrons are in a superposition of going through both slits at the same time, as if they're in two places at once. But note here, don't think of it like the electron has duplicated itself and there's literally two versions of the electron in each slit. Instead, think of it like the wave example. It's more like the electron is spread out across space. So the electron's behaviour is already very strange, but here's where it gets truly mind-blowing. When we try to measure which slit each electron passes through, so that we can try and figure out what's going on, everything changes. The interference pattern vanishes and the electrons behave as if they are individual particles again, producing the two clusters. It's as if the act of measurement forces them to choose a single path. So now, instead of behaving as if they went through both slits, they act as if they only ever went through one of the slits. So in other words, the act of measurement changes their behaviour. So to summarise the double slit experiment, I want to emphasise two key points. The first is superposition. Quantum systems seem to exist in an undetermined state until they are measured. It's as if they exist in multiple states at once. This phenomenon is called quantum superposition. In this experiment, the quantum particles behave as if they went through both slits at once. We compared this behaviour to waves, which raises the question, are quantum particles really waves when we're not measuring them? The truth is we don't actually know, because as soon as we do measure, they start behaving like particles again. Now, quantum physicists use something called a wave function to describe the behaviour of the particles when they're in this weird undetermined state. The wave function is a mathematical tool, and it gives us probabilities for finding the particle in a particular state, in a particular position, for example. Now, some physicists believe that the wave function represents a real physical wave. Others believe that it simply is a mathematical tool. One thing we know for sure is that quantum particles behave very weirdly when they're not being measured. Their state seems to be undetermined until a measurement is taken. The second point that needs emphasising is that measurement changes the particle's state. Specifically, the act of taking a measurement transforms the particle from being in this weird undetermined state to being in a definite state. This is called the collapse of the wave function. Essentially, all of the possibilities described by the wave function collapse into one of those possibilities, into one state. In the double slit experiment, particles behave as if they went through both slits, and then when a measurement is taken, they suddenly behave as if they only ever went through one of the slits. But why does measurement cause this collapse? This is the key question. There are many interpretations of what's going on here, but one interpretation suggests that consciousness itself could cause this collapse. If this is true, it means that consciousness could influence reality at the fundamental level. But how could consciousness have this effect? This leads us on to the model we're going to be discussing in this video. Now, I want to make clear that the model I'm about to discuss is not proven. It's simply an attempt at trying to explain how consciousness could cause the collapse, which itself is just one of a number of interpretations of the double slit experiment. With that in mind, the model that we're going to be exploring in this video is Chalmers and McQueen's consciousness collapse model. Their model basically provides a theoretical framework for how consciousness, this non-physical thing that we all experience, could have a physical effect on reality at the quantum level. So let's get into it. Since this model obviously revolves around consciousness, we first need to define consciousness, and there are two key aspects to it. The first aspect is the non-physical aspect of consciousness. This is our subjective experience. It's our experience of being conscious. Now, an example of this could be the experience of seeing the colour pink. The other aspect is the physical aspect. This is the physical correlates of consciousness. In other words, it's the brain activity that correlates to our conscious experience. For example, when we experience seeing the colour pink, there is physical activity happening in our brain that correlates to that experience. Now, the connection between these two aspects of consciousness is still unknown, and it depends on what philosophical perspective you believe in. For example, you might believe in materialism, which would suggest that consciousness is a product of brain activity, and so this is a simplistic version of it, but we could assume that consciousness and brain activity are the same thing. Now, on the other hand, you might believe in a dualistic perspective, which is the idea that consciousness and brain activity are two completely separate things. They're two completely different substances which interact in some unknown way. Both of these perspectives work with Chalmers and McQueen's model, but for the most part, we're going to be framing the model from a dualistic perspective, assuming that consciousness and brain activity are two separate things. So now let's look at the actual setup of the model. First, we have a quantum system. Let's use an electron. This electron is in a superposition. Its state is undetermined. Now, of course, the whole point of this model is to figure out how consciousness can cause this electron to collapse into a definite state. Next, we have a measuring device. This device interacts with the electron, which means they become entangled. This just means that their states are linked, so the state of one affects the state of the other. This is a very well-known phenomenon in quantum physics. So now both the electron and the measuring device are in a superposition. Normally, quantum decoherence, which just means when a quantum system interacts with its environment, would cause both of these things to collapse. But for this model to work, we need to assume this is an isolated system and that quantum decoherence isn't occurring, so instead we can focus on consciousness being the cause of the collapse. Next we have the researcher, who consists of two important aspects. So first we have the physical aspect of consciousness, which is the brain activity associated with the researcher's conscious experience. This brain activity is going to become entangled with the rest of the system, and so that is also going to enter a superposition. So now the electron, the measuring device, and the brain activity are all in a superposition. All of their states are undetermined. Finally, we have consciousness itself, the non-physical aspect of consciousness. The researcher's subjective experience of taking the measurement. Crucially, the researcher's conscious state is perfectly correlated to the brain activity. From a dualistic perspective, we can assume that there is some psychophysical law linking the two, ensuring that the physical and non-physical aspects of consciousness are perfectly correlated. So this is the aspect of the model that we're most interested in. What is happening here with consciousness that is causing the rest of the system to collapse into a definite state? So the key idea here is superposition resistance. We already talked about superposition, the fact that a quantum system can exist in an undetermined state, as if it is in multiple states at once. Now, superposition resistance is simply the idea that something resists being in a superposition. Now, two forms of superposition resistance have been proposed. One is a strong form of superposition resistance, also called superselection, and this just means that something never enters a superposition. So in other words, it is always in a definite state. Now, another form would be weak superposition resistance. This would mean that something theoretically could enter a superposition, but that superposition would be unstable and would collapse quickly. Now, what Chalmers and McQueen propose is that consciousness is superposition resistant, and this is how it collapses the wave function. So let's look at how this would work in practice. We're first going to look at a strong form of superposition resistance, which would mean that consciousness could never enter a superposition. So in other words, consciousness is always in a definite state. If this was the case, consciousness would force the entire system to collapse. This is because consciousness is linked to the brain activity, so it would force the brain activity to collapse, which would in turn force the measuring device and the electron to also collapse because they're all entangled. Now here's where we hit a major issue. If consciousness is completely superposition resistance, then we run into a problem known as the quantum Zeno effect. This is a phenomenon where frequent measurement prevents a quantum system from being able to evolve. So essentially it keeps it stuck in one state. To visualize this, imagine that you are trying to fall asleep and someone keeps poking you asking if you're awake. If they do this too often, then you are never going to be able to fall asleep. So you're going to be stuck in a state of being awake. This is what's happening in the quantum Zeno effect. Constant measurement prevents change. It keeps the system stuck in its initial state. So in our model, this would lead to two problems. Firstly, consciousness would be frozen in one state. In physics, change often happens through transitions between different states. And in quantum mechanics, this often involves transitions through intermediate superpositions. So in order for something to go from state A to state B, it would have to enter a superposition in between. If consciousness could never enter a superposition, this could mean we would never be able to transition between different states at all. Our consciousness might be stuck in the same state forever. For example, we might not be able to shift between different thoughts or different emotions, or we maybe wouldn't be able to wake up from being asleep. Another problem is that the entire quantum system would be frozen. If consciousness is totally superposition resistant, as soon as it becomes entangled with the quantum system, it forces that system to collapse into a definite state. This means the entire system could never enter a superposition, essentially freezing it in place. Both of these things are fatal problems because they essentially mean that nothing would be able to change, which obviously isn't true because things are constantly changing around us. So the strong form of superposition resistance obviously doesn't work very well for this model. So to avoid these issues, Chalmers and McQueen propose a weak form of superposition resistance. They propose that consciousness can enter a superposition, but that superposition is unstable and collapses quickly. This would prevent the issues of consciousness and the entire system becoming frozen, but it would still allow for consciousness to serve as the cause of the collapse because it would naturally tend to collapse anyway. So this new model fixes the quantum zero problem, but it creates a new problem. Now consciousness has to be able to enter a superposition, even if only for a brief period of time. So this raises a fundamental question. What would a superposition of conscious states look like? In other words, how could you be in two conscious states at once? A dramatic example would be being awake and asleep at the same time. But let's use a more simple example to try and see how this would work. Imagine seeing two different colours, seeing pink and seeing purple. So each of these is a different conscious state. So the experience of seeing pink is one conscious state, and the experience of seeing purple is another conscious state. So what would it mean to be in a superposition of these two states? The answer to this is far from clear. One potential option is that the superposition of these two states is not a total state in itself. In other words, there is something it is like to see pink, and there is something it is like to see purple, but there is nothing it is like to see both of these at once. Instead, the person experiences seeing pink and they experience seeing purple, but there is no conjoint experience of being in the superposition. Who knows whether this is possible? Another option is that the superposition of these two states of consciousness is itself a total state of consciousness. It's just a state that we're not familiar with. It could involve some form of combination of both states. So for simplicity, let's just imagine these two colours blended together. In reality, it would probably be some completely novel state that we can't even perceive. Both of these options are very strange and difficult to perceive, but superpositions of quantum systems are also very strange and difficult to perceive, and yet these are well accepted within physics. So if these superposed states of consciousness do exist, they clearly aren't something that we consciously experience in everyday life. So are they likely? There are a couple of potential answers to this. The first answer is that maybe these superposed states of consciousness do exist, they just exist for very brief periods of time, so we don't notice them. Another option is that some theorists believe that we're not actually aware of everything that occurs in our consciousness, so maybe we just experience these states unconsciously. In other words, we're just not aware that we experience them. This might be more likely if we again assume that these states are short-lived, and if we also assume that they're between very similar states of consciousness. So the colour example, for instance, as opposed to something like being awake versus being asleep. So assuming that consciousness can enter a superposition, even if only briefly, let's revisit our model and see how this would allow consciousness to collapse the wave function. So the electron, the measuring device, and the brain activity are all currently entangled and in a superposition. Their states are currently undetermined. Now we know that the brain activity is linked to consciousness. Either they're the same thing if we assume a materialistic worldview, or they are linked through some psychophysical law if we assume a dualistic view. Now we can assume that the researcher's consciousness enters a superposition, even if they're not consciously experiencing that superposition. And now, because in this model consciousness is weakly superposition resistant, the researcher's consciousness is going to resist that superposition, which means it's going to collapse quickly into a definite state. This causes the brain activity to collapse into a definite state, and because the brain activity is entangled with the measuring device and the electron, it's also going to cause those to collapse into a definite state too. So consciousness has now caused the entire system to collapse into a definite state. So through this model, we have just demonstrated how consciousness could theoretically exert a physical influence over reality, despite not necessarily being physical itself. Could this really be happening? Science hasn't settled the debate, but whilst this model doesn't prove that thoughts create reality like some manifestation teachers suggest, It does provide a scientific basis for the idea that consciousness could influence the physical world. And the fact that this is a possibility at all is truly mind-blowing. If consciousness really can cause wave function collapse, then perhaps our mental focus, our observations, our beliefs, our intentions can actually shape reality at the fundamental level. Let me know in the comments, did this model make sense to you? Are you as mind blown as me? If you are, please give this video a thumbs up. This theory is just one of many competing ideas in quantum physics, so if you want to understand another equally as mind-blowing correlation between manifestation and quantum physics, you can watch this video next. In this video, I explain how quantum physics might provide a basis for the idea that multiple possible realities already exist. Thank you so much for watching.